Also, as a reminder, for more Microsoft webcasts, you can visit microsoft.com/webcasts. And again, I'd like to welcome everyone to today's MSDN webcast, Management and Diagnostics for Windows Communication Foundation. And now, without any further delay, I'm going to turn the floor over to today's presenter, Mike Benkovich.
All right. Well, thank you, Tracy. I want to welcome everyone to today's webcast. We're talking about Windows Communication Foundation. This is one of the ones in the Framework Masterclass series that I've been doing, talking about some of the new technologies that are available. We're going to be diving into what is WCF from a management and diagnostic perspective, and I'm kind of curious to know from the audience what your experience is with WCF. Have you been writing applications? Do you have anything out there that's in production? You know, that kind of thing. That'll help us to focus our presentation. Today's presentation is at more of a 200 level to 300 level, where you've got some experience with it, you know about it, and you want to figure out how you can use it when you go into production to solve and answer your questions and problems. So from looking at this, I think that we're going to be at about where we need to be. Let's dive into the actual what it is we're going to be covering today. So what we're going to talk about is management and diagnostics of WCF, which is how can I tell what's going on inside my service without running it in debug. We're going to look at some of the tools and utilities that are available for it, and we'll look at specifically how we can do logging against information, the messages that are being sent back and forth, how we can do some tracing. We'll look at the configuration tool, performance monitoring, and then we'll wind it up with a little bit of working with the PowerShell to take a look at some of the management and diagnostic features that are part of that. So hopefully you got some experience with C#. It really doesn't matter what the language is that we're going to go out and create it, because we're not writing a lot of code today. But we're going to be looking more at how the communication is actually operating. So understanding the messaging fundamentals and some XML will be helpful in going through and doing that. So the plan is we'll start out with managing of WCF, Windows Communication Foundation. So when we talk about Windows Communication Foundation, it's really Microsoft's way of building service-oriented applications. It allows us to focus on the message there, the work that we want to get done. And using WCF, it's going to take care of moving the information from point A to point B. So instead of worrying about how we do COM or .NET remoting or MQ series or whatever, WCF takes care of that actual sending of the information from point A to point B. It really is a way of abstracting out the messaging framework. The nice thing about WCF is it allows us to be able to configure how that messaging is going to operate based on configuration. And all of that is stored in an XML format, which is easy to go out and read and understand what's going on, and it's open. It basically gives us the visibility into how we're going to be going out and doing the transport and what formats, etc. And it's really keeping this messaging configuration in an agnostic kind of a format. And then finally, the ability to go out and customize how it actually is going to operate. We can do that outside of the actual service that we create by looking at configuration and using the XML configuration tools. Now, in Visual Studio 2008, as well as in the SDK for Windows Communication Foundation, there's a number of really nice things that we're going to look at. The messaging and tracing show explicitly what is going on, and we can see it as it's happening and be able to feel or get a good feeling for how our service is operating. The performance counters allow us to catch and see through the Perfmon tool, performance monitor, different counters as different events are happening as the service is actually going out and running. Whether we use this alone or together, all these management features make it much easier for us to go out and really create a high level of availability for the services that we're developing. So when we talk about that, I mean, let's dive into how we go out and work on the logging. How do we capture the information about the messages that are going on? Logging allows us to go out and expose a lot of information about each and every message, but it's not necessarily turned on by default. And when we go out and create a logging, or we want to use logging, we need to have some sort of a process out there that's going to listen to the information that's going across the wire. What we do is we create a trace listener, and we've got a number of different ways we can do that, whether it's an XML trace listener or a trace listener that's going to the event log, or maybe to some custom database or whatever. But we need to set what that tracing listener is going to be. And then once we've done that, then we can go out and we can actually turn on what level we're going to be doing our tracking of the information and the messages that are going across. There's a lot of different levels that we can turn on, all the way from just a very few messages to very verbose logging, basically be able to capture every piece of information and everything that's going on inside of it. Now, we need to be a little bit careful when we do that, because when you start logging at very high levels, wherever you're capturing that to, you need to make sure you have ample storage and place to put it. We can also filter the messages that are going to be processing. For instance, in a high traffic environment where we've got a lot of messages going back and forth from a lot of different places, we can use XPath to filter down exactly, a particular application or a particular operation that we want to look at the types of messages. And we can also turn on how we want to do all of that matching based on the messages that are being sent through. The log file that gets created, if you're using the XML trace writer listener, which is pretty common because that's a default that's available when we turn it on, the messages are actually being captured as XML fragments that are logged into a file. And so we can go out and we can open up and look at that log file with an XML tool, although it's just a fragment of the XML. It's not a full, like where you've got an XSD file to lay out all the scheme and things like that. If it's a small file, you might be able to view it in Notepad, but there's a much better way of looking at in the SDK for WCF that allows us to be able to decode all of that XML information. This is called the Service Trace Viewer, and it's installed in the SDK directory for the WCF stuff. And you can use that, and it actually allows you a really good visualization of the messages that have been sent through. Now, the thing is that the WCF transforms that are running while we're processing the messages may not be exactly the same as the exact message that's going across, because things like white space and the empty elements, those are removed, as well as the personally identifiable information, or PII. Because if we're going to be capturing sensitive things like credit card numbers or usernames or whatever, we want to make sure that we can turn that stuff off. So in that case, what we can do, if you do need to capture that, is you can turn on the personally identifiable information. Let's see if we can get that to show up. By setting the enabled logging known PII, set that equal to true. And you can do that either at the machine level or at the application level. And what this does is then we will basically be able to capture all of that information that's going to be sent out to the log. So let's dive into our first example today. And what we're going to do is we're going to create a simple service, and we'll use the service library, which basically is going to get us to where we need to be. Now, you'll notice that from the Benko Tips, this is just a website where you can get more information. If you have any questions about this or other webcasts, I'll be posting the code from today out here, although there really isn't a lot of code that we're going to do. All it is a very basic kind of a thing. If you want to see the demo full screen, press the F5 key. That'll take you out to so you can see the whole screen. And at that point, you should be able to see my desktop is the same as yours. What we're going to do is we're going to create a brand new project. And what we can do is create a project using the WCF service library. Now, I'm using Visual Studio 2008, which is Beta 2, happens to have all of the different things installed here. I'm using the .NET Framework 3.5, so you need to make sure you're targeting at least the 3.0 in order to get the WCF stuff to run. But if you are targeting 3.5, and then you can see all of the templates that are out here. Under WCF, which is one of the folders here, you can see it on both VB as well as C#. You'll see that there is a WCF service library, and I will go ahead and create that WCF service library, and I'm going to put it into WCF service, and we'll put this into our FMC directory. FMC's Framework Masterclass, which is what this webcast is part of. Now, what happens with this template is that it allows me to go out and create a service that can be hosted in another process. I'm not worried about where I'm going to be hosting this. This is just that service library. And what the build of this type of a project gives me is an assembly that has the WCF service inside of it. And that service is defined by the contract and by the implementation defined in these two files. Out of the box, using the default template, it gives us basically a framework that we can go out and implement and run it. It's almost like the Hello World application that a lot of the Microsoft templates will give you. In this case, the iService1 contract is defined in iService1.cs, and what we can see here is my get data. Very simple, takes a integer and returns back a string. And then I have a complex one, or a composite type, where I go out and generate using data contract, where I pass in a composite type defined by my operation contract. That is actually using this composite type that is defined down below here, which has got a couple of values, a Boolean value and a string value. And just for purposes of this demo, we're going to leave this as simple as we can and just create the service. This is actually implemented inside of the iService1 file that goes out and does the implementation. Basically takes the data and converts it. Now, building and using this service is, we'll create the actual service that could be hosted somewhere. Where we want to host this is going to be driven from, our decision on how we configure the service. Now, the app config that's in the service library gives us a default configuration that we can use when we go out and test this. And inside of the app config file, what you'll see, let's open it up here, is that we have a number of different sections that make this all work. The key thing in building WCF things is that you have a namespace for system.serviceModel. And inside of service model is where we lay out what the endpoints are, the behaviors, etc. So I've got a couple services that are defined here. This is WCF service.service1, the name of the service. The behavior is defined out below. So I've got a service behavior that's defined down as service1 behavior, how it's implemented. Now, if you are like me and take a look at these, the app config file and trying to figure out what we want to put in here, yes, we do have IntelliSense. So if I was to click here and type, it's going to go out and show me all the other attributes I could be turning on. But knowing which elements to actually add, that takes a little bit of learning. There's an easier way to do that inside of using the what's called the WCF configuration tool. In 2008, I can right-click on here, and it'll go out to edit the WCF configuration. That opens up the utility that basically is taking that app config service model and then exposes it as all of the different properties and methods. And I can very easily, inside of this tool, be able to see, okay, what are my endpoints? So if I look in here, and by the way, in 2005, you can add this as a tool and be able to open it as well. But it's just slightly different. So what I've got here is the service file. I can see that I've got my service. It's got two endpoints defined, my WSHTTP binding, which is the default binding created for services, and then also a metadata exchange endpoint. That is the service, that's the endpoint that's used by a WCF client to get information about how the service is actually operating. If I take a look at the service itself and kind of drive through here, you'll see that here's my host. I don't have any hosts defined, but I do have a base address that it's going to try to host this off of. And then I've got my endpoints listed down here, and they just have an empty name. If I wanted to go out and create a new endpoint, I could create a new service, I could create a new endpoint. The endpoint, I could go out and define what type of contract I want, click on next, and then I pick the type of binding, whether it's TCP, named pipes, MSMQ, peer-to-peer. These are the communication mode that we would be using. So if I want to go peer-to-peer or maybe use the named pipes, I click on next, and then it gives me the actual address for this. So local host, and then slash service 1, and then click on next, and it basically says, here's what we're going to do is we're going to create a net name pipe binding using configuration, etc. I'm not going to do that right now. but that is how I could add additional endpoints to the bindings that I want to work with. You'll also find that my bindings, if I take a look at the bindings that are available, that list that I showed you for creating stuff is a subset of all of the different types of bindings that I could be using. So, for instance, the MSMQ binding or the net messaging binding, I can go out and I can configure exactly how that is going to work. And this should be our WSHTTP binding, and there's our contract. Now, the next thing to look at is you've got a client. So if you have a client defined, you would be able to go out and say, how's this client all going to work and what the metadata it would be using. I also have a spot for bindings, so I can create binding configurations. But the one that we're looking at today is really looking at our diagnostics. Diagnostics is where we can enable the logging and tracing of the information being sent across the wire. To take a look at what this has, you've got a message logging where we're going out and saying how are we going to log the entire message. We're going to take messages that are somehow malformed, like say we had an interruption or maybe the message doesn't fit what we expect. Do we actually want to be able to pull that back? I can turn that on and off. By enabling the entire message, when I turn that on, that means that it's going to include the complete message, including all of the information and all message levels. We can log stuff at the service level or transport level. Also, we can specify the maximum number of messages that we want to capture and the size of the message. So if you have very large messages and you want to throttle this back so that your logging isn't going to affect your performance, you can go out and do that. You notice there's no listeners and there's no sources created at this point. But when I go into the diagnostics, I can enable the logging by clicking on the Enable Log Messaging. That then turns on the actual logging and creates a default listener for me. And so this is the service model logging listener. That is a XML trace listener that will capture the information and log it out to a file. The file that it creates is going to be in, by default, give me my app messages at service log, which is going to contain whatever information I put in here, timestamp, process ID, etc. If you want to turn on as much information, whatever you need to be able to see what's going on, go ahead and turn that. That then will be visible when we view it in the trace listener. We also have a logging level, so I can turn on, do I want to include service messages, malformed messages, and transport messages. And then it also includes the ability for the timestamps, etc. Now you'll notice on the left that in the listeners and sources, we now have two sources created. One is my listener for my service model message listener, which basically maps out to the configuration that we put out there, and we're using the XML trace listener. You can see that there's the type name. And then I also have the source for the message logging. And inside of this, I can go out and I can say, what level do I want to trace at? And like I said, you can start it at a very low level, so I'm only getting just very minimal information, critical things that would be like the service exiting unexpectedly or something like that, all the way down to very verbose. And we're going to leave this on verbose just to create some messages for us. And then we can take this information here, and what we'll do is we'll save it. And what happens is that all of the information that we created inside of the configuration tool are now going to be updated and added to our web config, our application configuration file. So if I go out and reload this, you'll find that there's a little bit of additional information added back in here. So here's my message logging. There's my default trace listener. Here's the file that it's going to send the information to. The service log, you'll see that here's the type and the name, etc. All of this information then can be used to help us configure how we're going to trace the messages that are going to run through here. Now let's take this service, and we're going to start it up and run it, and we can debug it in here. Now you might be thinking, okay, well, but there's no host and there's no client. How are you going to do that? This type of project, a service library, is going to use a utility that is part of the WCF SDK that will go out and actually host it, and then also provide a client that will go out and expose it. I'll just start it up and you can see what's going on here. So it's going to go out and build it, make sure everything is right, and then the WCF service host window opens up. You'll see that it's trying to go out and start the services. And when I first do this, it'll take that service and it's loading up the metadata address. So it's using the MEX address for this basic service, the WCF SVC file. Then on the client, the WCF test client, you can see that here is how what services have been posted on here. I could exit here, but it takes a look at the interfaces and also the operations that are available for me to go out and work with this. Now, if you are on a machine and you're doing this for the first time and you get an error, there's an error that sometimes will occur. It's caused because of a missing bit of evidence on the assembly that runs the service util. So basically a message comes up saying, hey, you can't do this because service util is missing some evidence. What you can do to fix that is go out, run your command session. I'm going to do this as an administrative level, and go out and we're going to add a strong name evidence to that DLL. Now that DLL, the location where you want to do that is in the SDK directory, which is in your program files. So program files and SDKs, and I'm using some wildcards here because it's a little bit easier to do that. And if I press return, you'll see that I am in program files, Microsoft SDKs, Windows, v6.0a, bin. And then in here, if I take a look at for SVC star, you'll see that here's the service util file that is actually doing the hosting in my service host. And so what you need to do to make this thing work is I need to do SN, which is a strong name, minus VR, and then svcutil.exe. And what that does is it goes out and adds a verification entry to the assembly for service util. Basically, that means that when the security on the system is running, it's able to have that evidence it needs to allow it to run. You also see inside of this directory that we have the service config editor that we just looked at, as well as the service trace viewer that we'll look at here in a second. Now, we've got this up and running, and I've got my client is showing the services that are part of this. You see, here's my get data using contract. If I double click on it, it'll open up that client, so then I can go out and I can exercise the service. If I put in a 5 here and invoke, there's a nice security warning saying, do you want to send the information across? I'm going to turn that off for now. Say OK, and then it goes out and it's invoking the service. And so it's spinning up the service. It's going to go out and execute it, figure out what information needs to be sent back and forth, and then I get the response back saying, hey, look, you entered a 5, which maps out exactly what we did. If I want to, I can view the XML of this message by clicking on the XML tab, and I can see from a programmatic level what was the request and the response that got sent back and forth. Now, this is just the data as the program would see it on the sending and receiving of the information. The actual message itself, the actual what WCF was doing in the background, has been captured inside of that service log file. And if I go to the project, let's exit out of there, and then click on Show All Files, what you'll find is that this messages file is sitting right here, and I can right-click on, say, Open It, and we'll just open it with an XML editor to show you what it looks like. Contains one extremely long line of text. That's because this message, basically, it took that get message, do it was a Control-K, Control-D, which reformats the message. Basically, what I did was just reformatting the XML so I can see all the stuff that's out there. You can do that also from the Edit menu. I think it's under Control-K to format the document. That then allows me to see all of the information that went across. So the first thing that happened was here's my event going across, here's the type, here's the subtype, and I can see here's application data, all of the information that is part of what happened here. Now, if you're like me and you're looking to saying, you know what, I don't necessarily want to see how these messages are all being sent back and forth at an XML level, what you should do is you should close that out and open this instead of XML, right-click and say Open With, and then we're going to add that service trace viewer. And that's in that program files directory I talked about earlier. So to browse to it, you just go Program Files, and then Windows, Microsoft SDKs, Windows 6.0a, and then go to the bin directory, and you'll see in here there's a bunch of them, but the one that we're interested in is the service trace viewer. That gives us a nice viewer that's going to take this XML data, and it's going to presented in a easy to read environment. So we'll just go ahead and add that and say OK. And now when I double click on it, it'll open up this window with the activity that's going on. You'll see from that one message that there's 26 traces of information that went back and forth. I can actually click on them and get good information on, what was actually going on. You'll notice that there's a number of different threads that were created and used in the process of doing that one get data. And remember, we're logging this at a very high level, everything verbose. So we're getting all the informational messages. We're getting all of the, if there's any errors, we would see that. On the top, we can see the list of the messages, and on the bottom, I can see, the data that went back and forth. So here's the message log. It gives me the trace. I can see for each different piece whether or not there was, basic information, as well as, additional information. And I can view all of that as it goes back and forth. I can also go to the project and the message itself, and I can click on this, and I can see here's the message. Here's exactly when it went back and forth. And I can see this process, and I can see the activity, who it's from and to. I can also pull up a graph of it and see, here's the actual messages that's going back and forth. So if I'm looking for, what actually got sent back and forth, I can go into the message and see, what was part of that. But that is a much easier way to, or a much easier way of understanding the XML data that got sent back and forth, and it's all laid out in a nice, easy-to-use way. So that is how we can enable logging to get some good information. There are also the ability to go out and do some tracing. And so let's talk about tracing for a moment. We'll go back into our slide deck, and what we're going to do is we're going to talk about how we can turn on tracing to allow us to capture where logging is capturing the messages that we can put out there. We can also add trace messages that will enable us to see what's going on. Tracing features allows us to add milestones so that when we're going out and processing the message flow, it's going to let us create channels and messages. So we're actually getting down deep into how the channels are being created and the warnings and all the other pieces of the code. Traces also allow us to go out and see information from the assembly level. So from the service model, we can see that the service model logging of all stages of how that message is being processed, all the security, all of the dispatching of the user code, really allows us to get how those messages are flowing through the entire system. As with logging, tracing is turned off by default, so we need to go out and explicitly turn it on. The events that aren't going to be logged anywhere unless we turn on a listener, so we have to go out and create a trace listener. And then we can configure that trace listener to have different levels of what information we want to, what we want to capture and how we want to put it together. With tracing, we have critical, error, warning, and informational levels that we can be capturing. The choice of this is really, the size of the file and the information that we capture is, it grows very quickly. So when I'm going out and I'm running this, and particularly in development, and I go into production, I want to make sure that I've turned off the tracing or turn it down to a level that it will capture just the information that we really need to see. So that's important. The default trace listener is going to be the XML trace listener. That will take the debug output stream and allow us to capture it to the output window. But if we want to, we can send it to the event log trace listener or to an XML file. This is going to allow us to see what information are going through those messages. So what we're going to do is we're going to go out and we're going to turn on tracing on our project. So the next example is coming back into our project here. You'll see here's my app config. We've got logging is currently enabled. And what we'll do is we're going to turn off the message of logging and turn on tracing. So we'll go out to our WCF configuration tool. And again, this is literally going out and seeing what we've got out here. Clicking on the Diagnostics tab, you'll notice that when I disable the message logging, that the listener is still here. It doesn't delete it when you disable the logging. If you want to delete that, you can click on the delete and it'll actually get rid of that section. But we'll leave it there. We're going to turn on the tracing by clicking on the Enable Tracing. And then you can see what level we're going to be tracing at. We can trace it, again, at verbose, informational, critical, and whatever level we want to go out to. I'm going to set this down to the informational level and not do verbose this time. A little bit less information, but maybe a little bit easier to understand what's going on. Then we're going to go down to the service model trace listener, and again, I can turn on what pieces of information I want to include. Do I want to do the process ID, the stack, etc.? So right now our options are turning on this. It's going to create a file again that it's going to send us to. This is called my app trace log this time instead of service log, instead of app messages, and we'll capture our trace as we run through it. So let's go out, we'll close this, we'll save our changes, and we could take a look at the app config file and see how our trace has been turned on. Here's our default trace listener section added to the file. Let's go ahead and run the project. Should be able to just start this up. And once this is up and running, here's my host, and here's my client. And then we're going to go out and we'll run the project to work with. This time, instead of using the get data, the simple one, we'll just use the other method. Again, we're going to go out and we're going to change or set up our composite type. I've got two pieces of information that are part of that data contract. String values, say hello webcast viewers, and we can do the Boolean value true or false, go out and invoke the message, and again it's going to go out and run. If you look, you can see here's my configuration, and this has actually gone out and created the client configuration file. In case you're curious, it includes what does the client need to be able to connect up to the service and what endpoints are they using. You can see it's using the WSHTTP binding here. And it's actually one of the interesting points here too is that there is an identity that's actually tied out to the user that is doing the sending of information back and forth. That's kind of important to know. So here's our data contract we executed. We said hello webcast viewers, our return value. We can go ahead and close this out and see what was created. So let's refresh our files here. You'll see that here's my trace log. If I double click on this, it would open it up as XML. I don't think we need to do that this time. I'm just going to go out and say open with, and then we added that service trace viewer so we can view it through the service trace viewer to get information about what's going on. Now you'll notice that the trace viewer in this case has got a lot more types of activities that were going on. This last time we just had the list of what was going on. This is actually going on creating the service. It's constructing the host. It's going through. We've got listening. All the activities that are basically running. We had an exception that got thrown at some point when it was going out to do the metadata exchange. If I look here, it's changing a couple of other pieces. But really, I can go out and I can see all of the different information that has been processing. Now, in order to see the detail, again, click on that. But in this case, one of the interesting tabs is the graph. Because if I go out to my activity, and here's my activity, and I click on the graph, you can see that here's the graph of the messages that were processed across. And I can expose those out and see exactly what happened, where it happened, and how the actual messaging exchange back and forth was going on. And this is looking at the trace of the messages, which is in the application when we go out and construct different parts of the runtime. The trace will enable us to see here's something being created, here's all of those pieces. Message logging is where I want to actually write out a log of what's going on as opposed to trace, which is going to take the output and normally sends it out to the output console. This is literally allowing us to see those trace messages to a separate type of a location. So using this, you can see we've got the arrows that are allowing us to expand out how this message is being processed all the way out to the very deepest detail. And as you click through on the different applications and different pieces, you can see here's the endpoint, boundaries, etc. And this is some good information for being able to debug what's going on. Now let's go back. Now, if that isn't enough information for what you're doing, maybe you want to be able to get, maybe you don't want to have the tracing enabled and turned on in your configuration for how that service is running. Maybe what you need to do is to work with using a tool like Perfmon to actually monitor a live running service. Maybe you've got a service that is going out and doing credit authorization, and you actually want to see a graph saying how many times has this service been called, or how many exceptions have been thrown, or how many times did we have issues with how things are running. Perfmon allows us to do that by giving us counters that we can go out and add to our running process. Now, the performance counters that we can go out and turn on and off come at a couple of different levels. We've got 3 different categories: the service model service, the service model endpoint, and the service model operation. Let's see. And once we've enabled this, we can turn on what level of counters we want to do, and we can do it for particular threads or particular services and be able to work with that. A couple of ways we can do that. One is to go into the configuration file and add the configuration so that you can basically enable what diagnostics you want to do. So in this case, what we've done is we've gone out into our configuration and we said to enable the performance counters at all levels. We can also turn it on to be just service level. The other approach is to actually write code for that, in which case we go out and we add some code. In this case, what we're doing is creating in the application to open up the configuration and then set the value of how we're going to do the processing of that. Once we turn on the how we're going to be, WCF is going to be incrementing the counters, then we can look at the different levels. At the operation level, we can look at the service model operation performance object. This has, each operation in this case has its own instance, and a given contract, for instance, if we have 5 operations, there's going to be 5 counters for that contract. At the service level, this is where the service contains lots of operations. So this is going up a level to say, okay, well, here's all the service, what's that service doing, and what kinds of performance do we have on the service. And we could even go out to an endpoint and be able to add messages or the performance counters on the actual endpoints as well. So let's take a look at what it means to go out and actually turn on these different performance counters. So let's go back into our project here and click on this. And if you press F5, you can see the full screen again. I'm going to close out the trace listener, and I'm going to go back into our config file, edit the configuration, and in this case, we're going to go to diagnostics, and we're going to turn off tracing, and then we can go out and we can toggle the performance counters. Notice for the first time I do it, I'm only turning on performance counters at the service level. That means that just the service counters are going to be available so we can see how many operations have been run as opposed to the actual operational counters. By toggling it again, we're back to all, and it just, each time you click the toggle performance counters, it basically iterates through one of those 3 options. I'm going to turn it on so we've got all the performance counters turned on, and then I'm going to show how we can look at the performance counters. In your computer, there's a thing called Perfmon, and if you go to Perfmon and run it, what you'll see is that if you're running Vista, it's got to be, it's a system level thing. And from here, in reliability and performance, I can go to the performance monitor, which is the old performance monitor tool that's also available in XP and other places. But what you see here is a list of counters that are available for monitoring things. By default, I've got my performance or my processor time enabled. I can click on Add to take a look at other counters that I want to see. Now inside Perfmon, this webcast assumes you've got some experience with Perfmon. There's a number of different categories that I can choose for looking at. I can also go to other computers. If I wanted to browse out to a different machine, I could put in where my service is hosted, and then I can go and I can take a look at the service model endpoints. So here's the 3. We've got the endpoint. If I expand this down, you'll see that what we've got is we've got the number of calls, duration, how many failed. I've got how many faulted transactions that have flown through. lots of good detail on, like security even. From the service model level, I can go out and I can see how many calls were processed, whether or not the transactions flowed or not. And I can go down to the service model service, and at all of these different levels, I can go out and I can see different types of information, and actually have this charted on a graph while the service is out there running. So what I'm going to do is I'm going to go out and I'm going to add a couple of calls here. So in our service model endpoint, let's just go up here and collapse these back down. So in our service model endpoint, I'm going to go out and I'm going to add a couple of counters. I'm going to click on calls and calls failed. And actually we don't have anything running right now, so you don't see any instances of that selected object out that I could add. So what we'll do is we'll cancel out of this and we'll go out and start up our service. Before we do that, let's go into our actual implementation here. And what we're going to do is we're going to add something that allows us to track the value on get data. So I'm going to say if the value equals or is greater than 1,000 or greater than 100, then what we'll do is we'll throw a new fault exception. Error. Too big a value. So basically what I'm going to do is I'm going to run the process, or run the service, and I'm going to run it with different values, and I want to be able to trigger the fault by passing in values that are too large. So let's go ahead and start up our service, and when this is up and running, there's my host. Then I go over to my perfmon, and I can add counters. And this is going to connect to the services that are out here running. And so I can scroll down here to my service model, and here's my endpoint. If I click on calls, and let's go to MSAMPC, and we should see all of the information here. And let's go on to the test client, and let's try running this one. Invoke. This will start up the service, and then when I look at the counters, I should be able to see the service that's actually been implemented or instantiated. So if I come down here and I click on the calls or calls faulted, for whatever reason, I'm not seeing it added here. Try this again. And let's see. I'm not sure why I'm not getting the service up there and running. Oh, let's just restart the perfmon. Maybe that's the issue, is that it started before we knew that the service is up and going. So we'll start perfmon again. Continue. Go to my performance monitor. And let's add the counters, and let's scroll down here to where we've got our service endpoints, and then I can go out and I should be able to see the instances of these performance calls. And I don't see them. Why not? Let's go to MSAMPC. And let's just go ahead and add this. Here's my calls. And actually, we'll go ahead and add these for all instances. And call duration. And let's go to add the calls faulted. And here. And I'm not seeing the All right, for whatever reason, or what I should be seeing is on the graph, I should be able to see all of the charts, all the counters that are going across for this service. And this is running as administrator, and this is running as admin. You know what we didn't do? We didn't save this when we started. Let's stop the message. This is one of those important things that we do when we're processing is we've gone out and made these changes to the file, and I toggled this. You still need to save these changes, which then are going to update the app config file, which then we're going to go out and we'll restart this. And so now our service host is up and running. Wait till it's added. And then we'll start perfmon. Continue. And it's nothing like having real life stuff going on while we're out here doing this. All right. So now when I go out to my service endpoint, you should see that now I've got my service exchange for the iMeta exchange, etc. I'm going to add my calls and my calls faulted, and we'll do this for actually let's go down to model endpoint operation. So here's my service endpoint, and we'll add calls and calls faulted. Add those two, and I'm going to do that for the service one. So we're going to do this right here on this, right here, and we'll add. And I'm also going to do it for, that's the get data operation. I could also do the get data using the complex message. And then you have the meta exchange. But clicking OK here, you'll see that now we've got a couple of different charts here. Here's my calls, and the calls faulted. When I'm out running my client, and I go out to get data, and I call this, put a 1 on there, there's our value, process it, and then it's going to invoke the service, it'll run, and when it comes back, you can see that on my performance mine, you'll see that the chart here has gone to 1. And in fact, let's do this. I'm going to double click here and change the scale of this to be 10 so we can see it a little bit better. Say OK, and we'll change the scale of this one to be 10 as well. So that's that. That'll actually magnify so you can see right here is that line for the calls, and we'll highlight that line. And you can see there we've done this once. If I call this again, 3:30, invoke it. Each time I invoke it, I'll see if the number has gone up, and I can say, let's do this with a different value, say 300, invoke, and there's that call. I've got a fault, so I'm just going to do an F5 and close this. And then I look at my perf line, you'll see that my faulted message has gone up to 1. And so by doing this, you can see that in perfmon, it's going to track exactly what's going on, and I can see those counters as the service is running. The idea is that perfmon gives us the ability to see all of that information at a real-time basis. An example of where I've seen this used is like in a retail environment where people want to see how much have we sold. So they actually have perfmon tracking counters that are, each time the credit authorization goes through, maybe with a dollar amount, it's able to add a counter to the number of calls operated on. So that is how we can go out and view this inside of using the performance monitor to see the information that's going back and forth. Now the last thing we're going to talk about is looking at how we can go out and use PowerShell, which is a vast improvement to how you can go out and monitor and work with things. The command shell was a nice utility for going out and making changes and seeing how I can go out and script things. But PowerShell is an entirely new way of managing the entire system, because we can literally go out and run Windows executables like we normally have, but we can also use managed code. So I can go out and create managed codes called commandlets, and then be able to go out and run them, basically script them together and use the object-oriented capabilities of it. The real strength of this is that we're able to go against all of the different management features. So I can use PowerShell to go out and get those performance counters and see the management instrumentation, get to the registry, and be able to query stuff. But beyond the query is we can also report it back in ways that would be pretty challenging just using the regular command shell. I can use different filtering, so I can use SQL-like filter clauses to pull back particular different things. I can format the output as tables or as lists. The main use of PowerShell in WCF applications is looking at your Windows Management Instrumentation, or WMI stuff. There's a lot of information that gets exposed through the WMI provider, and if we enable that, then we can do that inside of our configuration to basically turn that on, and then we can query it inside of PowerShell. Once we get into PowerShell, then we have the prompt that allows us to go out and call different commandlets. The commandlet that we're going to look at is the get-WMI object, which returns back information, and we pass in what namespace and what information about it. This allows us to display all of the properties of what's going on with our service. And then the output of these is returned as a collection of objects. So I can see what types of objects we're looking at, how many, what are the endpoints, whether or not we're tracing, and we can basically configure how we're doing our management using the PowerShell. So let's go in, and I've installed the PowerShell utility, or the tool, on my machine here. So let's go back to my machine. And if I go to my PowerShell commandlet, you'll see that right here, here's the Windows PowerShell. Right-click on it. I'm going to run this as administrator so that it's running at an elevated level. And the reason why is that I want to be able to see some of the administrative types of tools and utilities. So what we're going to do is we're going to start out, and we're going to just kind of give you an idea as to what's here. If I do a dir, like you would expect for a directory, it'll go out and pull back the directory wherever I happen to be, which in this case is my system32 directory. But let's cd / and I'm going to say get child item. And this then goes out and will return back all of the information from the directory. Again, it's basically an alias of get child item is the same as for the other. Now the commands that I can run, if I go out and say get command, and we'll pipe this into the more object, that allows me to see all the different commands I can go out and use. So the commandlets that are available are pretty extensive. Press enter to, or space to get to the next page, and you can go through and you can see that there's a lot of these things that we can take a look at. Let's do this, PS drive. You can see the different objects that I can operate against. I've got certificate store, I've got my file system, I've got environment, registries. I can go out and I can explore different pieces of that. So for instance, if I wanted to do a view of what's in my HKey local machine, I can say get child item, and then pass in HKeyCU, right, HKey current user, and this then pulls back all of the different parts, the registry key for the HKey current user. And if I wanted to say, let's take a look at my HKey /system, I can see what is inside of the system directory or the system registry key. Now, to get to the WMI objects, what we use is the command that's called get WMI object. And then I'm going to go out and pass the list. This is going to actually return back a list of what the objects are that I could be viewing at. Control C. Here's my. There's also a couple of aliases or shortcuts that I can type in. So GWMI is the same as get-WMI object, and I can say Win32 environment. And that'll then return back my environment variables that I've got set for how this is working. Now, Windows Communication Foundation exposes lots of information through here. So what we're going to do is we're going to enable our application to send us information about the WMI stuff, and we do that inside of our appconfig inside of WCF. So let's switch back over to the WCF project, and I'm going to open up and edit the WCF configuration. And then I'm going to go to my diagnostics, and what we'll do is we'll turn off our performance. Oh, we can leave those turned on. But I'm going to go out and I'm going to enable the WMI provider. So we'll go out and turn that on. And then once that's been done, we'll go ahead and make sure we save it this time. Yes. Then from the Windows PowerShell, I can see what's going on with this process, or with the service. So we'll start this up, and we'll have this up and running. And then I'm going to go out to my Windows PowerShell, and then I can use the command GWMI to get information about our service. So we'll do a GWMI. I'm going to pass in my namespace. And the namespace we're going to look at is the service model. So I'm going to the root and / service model. And then we're going to pass in the class of what we're looking for. And this will actually pull back, actually just a list, and will show me all the different objects that are part of that. And make sure you type this in correctly. There we go. And we can see here's all of the different parts of information that can look at context binding element, my pure transportation element, all the security settings. If I do this and I pass in a particular one where I want to see, like the endpoints, we'll set our class as equal to endpoint. And this is going to return back the endpoints that are exposed through my service. And let's scroll this up a little bit so you can see the endpoint that is part of this. You can see here's my my local host. Here's my metadata exchange endpoint and all the details of that. I can also go out and pull back the contracts. So if I want to pull back to the endpoint, I can pull back the contracts. Contract shows all the different contracts and information that's available as well. Now, and then we can also change it to a different computer. So, for instance, if I wanted to, I could say, look at the contracts for a particular computer name. And then we'll put in whatever the machine name is. The dot is a shortcut to this machine. But if I wanted to see the information on a different machine that I had the administrative rights to go out and do. Now, we can also create shortcuts or aliases of our own that we want to use that are going to equal different commands. The way we do that is I'm going to set like a variable name using the key, the $sign to specify what it is. But I'm going to set this variable is equal to the GWMI, and then we'll pass in namespace, and then use the root / service model, and then class contract. And this then is going to take a variable, and anytime I run var, $var, it will return back that information. And what's interesting is that I can then, using this, I can also put in filters and be able to pull back pieces of information. So using that same command, I'm going to pipe this into the where. I'm going to pass in where, and I'm going to say the name is equal to, and we'll pass in the name of iService. Okay, iService1, I think, is what we created. And then you can see that I can filter down which pieces of information I want to pull back. I can also then pull back particular fields. So maybe I want to do a select on this. So I can pass in select. And what do we want to select? We'll select back, say, the name, the namespace, and the operations. And we get back 3 columns that are part of the information that was pulled back from that WMI namespace. And we could even take this same stuff, and we could also format it as a table. And the format table will take the data and pass it back to the table, or we could pass it out to a file. We take this and pipe it to an out file. Out file, and then put in WMI.txt.